So the first thing we have to do in any graph that we use transformations is to recognize what is the parent graph. So we're going to graph y equals 2 to the negative x plus 2. And when you're looking at that, you have to say, well, where's my x? What kind of function is this? And to notice, I know this question kind of tells you already. It says, gives you the hint of what the parent graph is. But in most exam questions, you'll just get this and be asked to graph it. So the question is, can you recognize that that's a 2 to the x graph that's been transformed? You have to look at, where's my x? My x is up there in an exponent. So what's the base of that exponent? That's my 2. And everything else is transformations. So one of the things that makes exponential graphing a little bit more difficult is it's not quite as easy to see what's inside the function, what's outside of the function. But again, you start off, for our graph, you start off with your parent graph and draw a quick sketch off to the side. You know these 2 points, 0, 1, 1, 2, and you know that it has an asymptote at y equals 0. So there's our parent graph. Now if we're going from left to right, we have to decide what's all happening here. What do you think the 3 does? Is it going to affect the y or the x? Is it inside the function or is it outside of the function? It's outside of the function. So what did we find out from our transformations? Everything outside of the function affected the y. Okay? And so when we talk about inside the function, we're talking about things where the x is. And so anything inside that exponent is going to be inside the function. Anything outside of the exponent, that's going to affect your y. So this is going to be a vertical stretch. We're going to multiply all our y values by 3. What will the negative do? It's going to be horizontal because it's inside. Horizontal reflection. Which way does it go? Over the x-axis or over the y-axis? X, y, x, y. Okay, let's just go back and forth, and whoever's loudest last wins. So what value is this affecting? It's affecting your x value. Think about an x coordinate and make it negative. Where does it go? It goes over the y. So this will be horizontal over your y-axis. Probably the easier thing to do, though, is think about algebraically what's happening is your x values getting multiplied by 1. And finally, we've got a 2 here. Can you see that that's inside the function? That's a horizontal translation. Which way will it go? Left? Right? Left? What do we know about things inside? Do they go opposite of what they are, right? And so we see a plus 2, so you think you go to the left. Unfortunately, this one goes to the right. How come? Because you forgot something. You have to factor it out. Boy, they just, very first question, eh? Very first question comes with all the bells and whistles, the factoring thing that you always forget, and the hardest factoring when it's just an incy-wincy little negative out in front. That's the most difficult one to see because it's hiding there, right? And you're like, oh, don't think negative, and you ignore it, and it gets you every single time. So it is 2 to the right because I'm going to rewrite this. This is really 3 times 2, and you'd have to factor out that negative, which would make it x minus 2. So you were right to think the opposite, but you just had forgot to factor out first. So what does this mean for our graph? How do we go about graphing this? Well, we do the same idea that we've done in transformations. You take the 2 key points that you know. We know 0, 1. We know 1, 2. we also are going to worry about what happens to our asymptote at y equals 0. We'll do that last. Remember doing this with 2 sections of points? You did all of your stretches, compressions, and reflections first. So in this case, what are we going to do? We're going to multiply y by 3 and x by a negative 1. What happens to these points? Well, this will still be 0, 3. This one will be negative 1, 6. And then we do all of our translations. In this time, we only have 2 to the right. So this will become 2, 3. And this one will become 1, 6. The only thing that's going to affect your asymptote at y equals 0 is if you move things up or down. Can you see that we have no translations up or down? So our asymptote is still at y equals 0. So once you have your new points, you can sketch